The efficacy of curcumin in topical application. In summer 1, we're focusing on making a turmeric sunscreen. I'm Alex Griffith, I'm the project leader. Our mentor is Dr. Koyaglu.
I'm Hadil Darwish.
I'm Hadassah Arisha.
And I'm Heidi Muhammad.
Okay, so turmeric has many health benefits and properties. It's antibacterial, it's anti-inflammatory, it contains antioxidants, and also antimicrobial.
Oh, sorry.
So why use curcumin in a sunscreen? Well, curcumin is actually a compound that is in the main ingredient in turmeric, so it may inhibit damages caused by a reactive oxygen species, which is harmful to our bodies. It also has anti-inflammatory properties, which for sunscreen, it's basically an inflammatory, for sunburn, it's an inflammatory response. So its anti-inflammatory properties will actually help with that. And also is effective in blocking UV rays.
Okay. So we passed around the turmeric plants, and curcumin is actually extracted from turmeric, which usually comes into powdered form. So what we did to extract the curcumin, we have like an extraction process. We did it one time with dehydrated alcohol and one time with methylene chloride. And the extraction that we did of curcumin, we used to actually produce the creams. So a big part of making the creams was the synthesis of methyl stearate, and methyl stearate is basically an emulsifier for creams, and we used it also into making the sunscreens. Okay, so to make the actual sunscreens, we kind of had like an assembly line set up, and an assembly line to mix the ingredients together. And as you can see, the creams had different concentration of curcumin, and those samples that we got, we actually tested it for UVA and UVB radiation. We tested how efficient it would be in blocking the UVA and UVB radiation. And it turns out that our compound completely blocks the UVA and UVB radiation, and it is superior to anything else like on the market right now.
So to test our product, we use the HPLC, which is a high-performance liquid chromatography. Our product is confirmed that the yeast is able to produce a noble compound, which is really good and strong observation at 440 nanometer. We also use the UV instrument to measure the wavelengths, and the IR instrument to confirm the product. So we found that our product is very effective with the gram-positive bacteria.
So the structure of curcumin contributes to its medical properties and its color. So what you see here are a number of chemicals that are in sunscreens. They're called chemical blockers. And if you'll notice, their structure are quite similar to curcumin, but they're not exactly the same. I want to point out avobenzone because that's a very common blocker. It's in most sunscreens, but it's a carcinogen. Now, curcumin is similar, but it's also anti-cancer, antibacterial, antifungal. So I used Argus Lab to render these molecules, and Argus Lab can determine the lambda max of a compound, so we can figure out what color it is and what wavelength it absorbs. So curcumin absorbs at 421. Avobenzone, which I mentioned before, is very similar. Again, if I cut curcumin in half, it's almost exactly the same, which means it's a symmetrical compound that only half of it is responsible for its color. Even aquocyan, which is a much smaller compound, has a very similar lambda max. Now, when I reduced curcumin with ADH, which means I got rid of the beta-diketo groups and made them a diol, look how much it dropped. It's enormous. That's an enormous drop. So when we did the actual reaction in the lab and not synthesized on a computer, I was able to get this lambda max, which is incredibly similar. That's one way we've confirmed that we have a new compound, and it's probably what we think it is. Now, if you see here, there's a little bump. It might be hard to see, but I can see it, I promise you. That says that we still have curcumin in our solution. And HPLC has also confirmed that we still have a lot of side products. So our next steps are going to be cleaning up this reaction considerably. We have so many side products, and we need to identify just the one that we want. So we want to further quantify this reaction as well. We're doing that with a partnership with Rutgers and NGIT, so we're going there and we're using their equipment that we don't have here. It's very expensive equipment, it's enormous, so we're very lucky to be able to have that partnership with them. Once we reduce it completely and isolate it, we're going to test it as a UV blocker, because not only is it less staining than curcumin, it has better antimicrobial activity and is a better UV blocker, which is why it's definitely going to be something marketable if we're able to succeed. So if you want to come visit us, we're in SA 116. We're down in the chemistry wing. Let me know if you want to stop by. All right, thank you.